Hey guys, it's Mr. Sokol back again. We're going to do the second half of this. The first thing we need to do is talk about, what it looks like when we have a transformation of our inverse trigonometric functions. And really, if you think about it, it's basically the same thing as those other transformations, except the what happens if we're stretching this. So let's go ahead and look at it. The cool thing about this is that there are two repetitions of this within one space here, so that's cool. We're basically just changing the period of this cosine, this inverse cosine function, but let's remember back. What did our inverse cosine function look like? Remember, the regular cosine function is from 1 to -1, and it starts high and it goes down low and it comes back up here, right? And we had to restrict it to half of its movement, right? Or else we couldn't have an inverse function. So we went from 0 to pi, right? And those were our x's, 0 to pi. Well, that 0 to pi will now become our y, right? So 0 to pi. And I'm going to graph the parent inverse function first, and then I'll graph the other, the transformation. And you're going to see that basically this fits within half the space of this. Okay, and so its new domain, the inverse domain is, let's just go ahead and do -1 out here to 1. Okay, and so if I just wanted to graph this, remember our coordinate pairs just get flopped. So we had -1 to pi, and that was the end of our other function, right? And then we had this guy right here. And across right, it crosses at pi over 2. And then we just had a little bit of a curve. It comes down here. And it goes down there. And I'm sorry, that's not a really good drawing. I didn't draw it very fast, and I'm drawing it pretty large because I want to go back and I want to draw this guy. This guy, believe it or not, does the same thing in terms of range, but its domain gets cut in half. And I know I didn't draw a perfect half, and I'm using the wrong color. Change the color now, fix it up. That's -1/2 and 1/2. And basically by doubling this up, you're shortening the size of it, but it goes up here, comes down here, and it'll still cut through the same spot. So, woo! There we go. Wow. Rented tools. There we go. All right, so that's what it looks like. All right, and you can do transformations with all sorts of things. Just remember that all you're doing is flip-flopping by looking at the coordinate pairs on the unit circle, and then flip-flopping the x's and the y's, and you can get this done. Super simple. And if I had a transformation that said +1 over here, I would just take this and shift it over one space, right? Or I'd shift it up. Okay. I hope that makes sense. I'm going to clear the whole thing because I want to get to the next page. The next page of your work. You're going to love this. And when I say you're going to love it, you're probably going to cry a lot. Crying is good. Crying is what keeps us healthy. We're going to start talking about triangles and how by drawing a triangle, we can figure out some compound trigonometric functions. So let's go ahead and look at something super simple first, right? And we don't need the unit circle for this per se. We just need to be able to draw a triangle. So if I have, for instance, I'll use something super simple. I'll say that we have, I don't know, the sine of the inverse sine of -1/4. And I'm sorry about the writing, but there it is. So the sine of the inverse sine of -1/4. And, oh, sir, I can't find -1/4 on the unit circle because it's not given to me in pi radians, and it would be in between some spots, and I wouldn't be able to find this. So I say, hey, well, that's okay. Just think of it as a triangle that goes down one, right? Oh, that's a horrible triangle, sir. You suck, sir. Your triangles are horrible. I don't think I can draw a triangle from this, right? But I can do it with this guy. Let's see if... I think if I do this right... Yeah, there's the right triangle piece. And then ding. All right, well, can't do it, can I? Okay, so I'll just try and rough it. Or I won't. I gotta get rid of that crap. Sorry about the wasted time. So we got a right triangle. Looks horrible. But if I put a 1 out here, and this is the angle that I'm talking about. So the inverse sine is telling me it's one opposite over hypotenuse. Woo! Not writing well at all today. God dang, let's get rid of this whole thing. You're going to be so mad at me by the time this is all over because I'm so bad at editing and I don't take the time to do it. You're going to yell and scream and jump up and down. So let me set this down and I'll just go nice and slow. So much better. And this is a 1 and this is a 4. Don't know why this took me so long. Anyway, the inverse sine, that's the angle. So, okay, well that's great. So the inverse sine would give me theta, right? But then, so what? Now I'm going to take the sine of it. I want to know what the ratio is. I want to know what opposite over hypotenuse is of -1/4. Well, it's that same spot. So this ends up being theta, right? It just gives me that thing, and then it says, well, what was the sine of theta in the first place? And we say, well, it was 1/4, -1/4. All right, so good. These two things cancel each other out, and here's your answer. So if we have sine, inverse sine of -1/4, everything's super simple. All we do is you've been given the answer. So what if I say, let's see if you guys can do this. I'm going to stop the video for, or have you guys stop the video for a second. I'm going to say, what is the inverse cosine, of the cosine of pi over 2? right? And then you can use the unit circle for this, right? Pi over 2, the x value is 0, right? And so the cosine of pi over 2, that angle, or that x value, there's the angle. The cosine of the angle of pi over 2 is 0. And so what is the angle that gives us the cosine of 0? That would be pi over 2. So basically, if they're inverses of each other, they just cancel out, and there's your answer sitting right there inside the parentheses. All right, and it's going to become a little bit more difficult. There's going to be a little bit more that we have to do with it, but that is talking about compound functions for us. There are going to be tricks in here, and I'm going to show you one trick right now. Here's the first type of trick. They'll use the word arctan. What's the arctan of the tangent of pi over 2? Remember pi over 2, right? We were just there. And the coordinate pair at pi over 2 is 0 and 1. Uh-oh. So sine over cosine, right? So the y value is sine, and the cosine is the x value, and tan, remember, equals sine over cosine, right? Well, wait a minute. That's going to equal the tangent of 1 over 0. Wait a minute. The tangent is 1 over 0. Well, that's undefined. That doesn't exist, right? So I can't find the inverse tangent of something that doesn't exist. So if this doesn't exist inside the parentheses, we can't find the inverse tangent of it, okay? So yes, you will be tricked into thinking, yeah, well, we could say that this is, we could say that this is still pi over 2, but in essence, because this doesn't exist, then we can't do any mathematics with it, all right? Sometimes they'll give you a value that's outside the boundaries of what we're allowed to be looking at. Remember, tangent, when we're looking for inverses, we're looking for inverses between certain boundaries, or no, they'll try and trick you. So look out for those tricks outside the boundaries. So here's something that might be given to you. Sine. What is the sine of the inverse sine or arc sine of 4? Right? But there's no such thing as the inverse sine of 4, right? Because we can only go up between -1 and 1. That's it. So if we have a value like this, it doesn't exist. If this doesn't exist, then we can't find the sine of that. Okay? So watch out. They're going to try and trick you with a couple of these things. And I hope that makes sense to you. One more little piece of information, I think. And then you're pretty much done with this nonsense. Well, you're not done with this nonsense, because we're going to start using this nonsense with our wonderful trig identities, or the law of sines, or the law of cosines. Good stuff. All right. So here's my last one. Here's the last one that I want to draw. Actually, I want to draw 2 more. No, I don't. I want to draw 1 more. So I'm going to change the color. I'm getting bored with that color. What is the cosine of? Because we're going to mix our trig functions. what is the inverse of, what is the cosine of the inverse tangent of negative 3/4? What in the dickens? Oh my gosh. Well, I don't know anything about negative 3/4. It doesn't give me anything cool on the unit circle. I can't go find that real easy on the unit circle. But what can I do? Yes, you're right. You can draw the triangle. So you know that if theta is your angle, right? Theta is your angle, and opposite from it is -3, and adjacent to it is 4, because that's what gives me tangent, right? And all we're going to use is the Pythagorean theorem to find the hypotenuse, because then you can tell me what that cosine ratio would be. This says the inverse tangent of 3/4 is theta, right? Or negative 3/4 is theta. So all I'm going to do is say, hey, you know, what would the hypotenuse be? And it'd be 5. It's that special right triangle, 3, 4, 5, right? And if you didn't know that, you could use the Pythagorean theorem, you know, 16. 4 squared is 16, 3 squared is 9, 16 plus 9 is 25, and then there you go. Take the square root, and there you have it. All right? Cool beans. We now can find the cosine of theta, because that's what is sitting in here now. It's theta, because we found, we would find the angle theta. What is the cosine of theta? That gives us this. And we would say the cosine is adjacent over hypotenuse. So the cosine of all of that in there is 4/5. It's a long explanation just to get to that simple answer if you could draw the triangle. And you might have been able to do it yourself, and congratulations on being able to do that, because that means you're thinking ahead of the game and you don't have to have me show you. And that is the hardest work that there is to do. There's one more piece of information that's going to be on your practice worksheet. And it says, use algebra, right? And I want to find the actual wording. Just give me 1 second while I bring up the book to tell me what they say. Come on, algebraically, here it is, come on. Oh, I was right there. Algebraically, yabba-dib-yabba-dib-dib-dib-boo. There it is. Okay. It says, write each expression as an algebraic expression of x that does not involve trigonometric functions. All right, so basically all you're doing is writing something that has to do with x. This is, I would say it's a tough piece for you guys, but I don't think if I draw this out, I think you're going to get the idea. Here we go. So this says, draw this out as an algebraic expression. Sine of arc cosine, right? Arc cos of x, right? All right, well, we know one thing, right? So x, arc cos of x, we're going to draw a triangle. Because our ratio is basically x over 1. That's our ratio, okay? Arc cos of x over 1 gives me theta. So I'm going to draw myself a triangle. Any old triangle, any old right triangle is going to do, because we don't have any cool values. We only have 1, because we love that unit 1, x over 1. So if we put theta here, this would be x. All right? And now all we need to do to find that sine ratio, or to find that sine, is find out what that opposite side would be. Well, using the Pythagorean theorem, remember this would say that 1 squared equals x squared plus all what you're trying to find, right? And so if we undo all this stuff and we rewrite it, because we can also write the square root of c squared minus a squared equals b squared. That's also, b equals, sorry. That's also a way to write the Pythagorean theorem if you're given a and c, right? So that's how you find it. So let's go ahead and not talk about it that way, but let's go ahead and do this. So this would be the square root, this over here would be the square root of 1 minus x squared. Okay, well, this is definitely 1 minus the square root of 1 minus x squared. And that's a perfectly valid answer. Let me get rid of the junk that's in the way here. I want you to be able to see it. Poopy. I'm so bad at this. There we go. At least it's a little bit cleaner. I don't want to waste any more time. So that is your answer. This is it in a nutshell. So what you would then do is say that the sine of theta, which you figured out the triangle for, what it's going to be equal to is the square root of 1 minus x squared over that 1. Well, you can just get rid of that 1 and just say that your answer is right there. Okay, and so you have a couple of problems on your page that look like that. That's it. So you've had 2 20-minute videos, and you're now able to take care of this. And I'll see you guys soon.